Welcome to the Chemistry, Biology and Math Revision Hub. Today we are doing the Pearson Edexcel International A-Level Chemistry Unit 2 for January 2020. This is the Part 1 video for Section A. I'll put the link to the Part 2 video below the description box. Let's begin with the first question. Question 1 says, which equation represents the standard enthalpy change of formation of hydrogen iodide? You need to remember that standard enthalpy change of formation is when 1 mole of hydrogen iodide is formed from its elements at standard conditions. So in this case, when we look at A, hydrogen element is not that, so iodine element is not that. Here we could assume it's okay, however, the product is 2 moles and therefore that disqualifies B. For C, we can see 1 mole of hydrogen iodide is produced, however, hydrogen is a gas, but iodine is not a gas at standard conditions. So D is the only correct answer because iodine is going to be a solid, hydrogen is a gas, and 1 mole of hydrogen iodide is produced. So that is our answer. Moving on to question 2, they say when 50 centimeters cubed of hydrochloric acid of concentration 2 mole per decimeter cubed is added to 50 centimeters cubed of sodium hydroxide solution of concentration 2 mole per decimeter cubed, the temperature increase is 13 degrees. This is the equation for the reaction, and they say the experiment is repeated using 25 centimeters cubed of the same hydrochloric acid and 50 centimeters cubed of the same sodium hydroxide solution. They ask you what is the temperature increase. Here they're asking for the temperature increase for the second experiment. So in my calculation, I separated these into 2 experiments. The first one is this experiment, and the second one is this one here. So from the first experiment, we expect that delta H is going to equal to Q over N. And by the way, for both experiments, we expect the delta H to be the same because 1 mole of sodium chloride and 1 mole of water is produced from 1 mole of hydrochloric acid and 1 mole of sodium hydroxide. So in this case, delta H will be Q over N, which is equal to mass times the specific capacity times the delta T divided by N. Now, for the first experiment, the mass is going to equal to the total volume, which is 50 plus 50, which gives me 100 grams, if I am taking the density to be 1 gram per centimeter cubed. And then the number of moles, since equal number of moles were used, because here we can see number of moles is concentration times volume, the concentration is 2, the volume is 50 divided by 1000, which gives us 0.1 mole. So for both, because everything was used up, there was no limiting reagent, the number of moles are going to be 0.1. So delta H1 should be 100 times the specific capacity C times the delta T, which is 13 divided by the number of moles. Of course, this is an exothermic reaction. Even if I don't put the negative, it's okay because they will cancel out either way. From experiment 2, the moles of hydrochloric acid used were less than those used from the experiment 1 because the volume was lower than the volume used previously. So here number of moles is concentration times volume, which is the concentration times the volume used, giving me 0.05 moles. However, the moles of sodium hydroxide remain the same, which is 0.1. So here we can see hydrochloric acid is going to be the limiting reagent, and therefore we are going to use its number of moles. Here I included HCl is limiting, so the number of moles we're going to use as 0.05 in calculation of delta H2. So when we get that total mass is going to be total volume, which is 25 plus 50, giving us 75 grams. Again, here the density is approximated to equal to the density of water. The number of moles is 0.05 mole, so delta H2 should be mass, which is 75, times specific capacity, times the delta T we are looking for, divided by the number of moles, which is 0.05. Equating delta H1 to delta H2 and cancelling out the C's from each side, we can make delta T the subject, and it came to be 8.7. Therefore, my answer should be a C, which is 8.7 degrees. Question 3. Nitrogen reacts with hydrogen to form ammonia. So here they've given us the equation for the reaction and the enthalpy change, which is negative 92 kilojoules per mole. They've given us the bond enthalpies. Here we have the nitrogen-nitrogen triple bond equivalent to that, and the hydrogen-hydrogen bond equivalent to that. The question is, what is the main bond energy in kilojoules per mole for the nitrogen-hydrogen bond? We need to know that enthalpy change is equal to the summation of the bonds broken minus the summation of the bonds formed if we are using bond enthalpies or bond energy. So in this case, negative 92 should equal to 1 nitrogen-nitrogen triple bond, which is 1 times 945, plus 3 hydrogen-hydrogen bonds, which is 3 times 4, 36. However, we know that each ammonia has at least 3 hydrogen-nitrogen bonds. And in total, since we have 2 ammonias, we're going to have 6 nitrogen-hydrogen bonds, and that is what I showed here. So substituting for this and that and making this the subject, a single nitrogen-hydrogen has 390.83, and the closest answer is 391 kilojoules per mole. Therefore, D is our answer. Moving on to question 4, they say, how many moles of carbon dioxide are formed when 3 moles of chloroethene, which is this, is mixed with 10 mole of oxygen and react as shown below? So here they've given us the equation for the reaction, and we know we have 3 moles of that, 10 moles of that. However, we have to use the mole ratio from the equation to know how many moles are going to react. I'm talking about moles of oxygen. So we know that the ratio should be 1 to 2.5. If we have 3 moles of chloroethene, we'll need 5 divided by 2 times 3 moles of oxygen, which is 7.5 moles. And that means 2.5 moles of oxygen are going to be excess. So we can see that oxygen is in excess, and therefore we can safely use the moles of chloroethene to determine the moles of carbon dioxide that is going to be produced. To do that, the moles of carbon dioxide will be 4 divided by 2 times 3, which is equal to 6 moles, and the answer here is going to be 6. Question 5. Which compounds are arranged in order of decreasing boiling temperature? Here we have to look at the branching that exists within the compounds given, because branching decreases the boiling point. And from my observation, I can see the order of decreasing boiling point is going to be B. In this case, if we look at C, we can see this one has 1 OH, this one has 2 OH, and that has 3 OH. So this is increasing boiling temperature, and the only possible answer with decreasing boiling point is supposed to be a B. Moving on to question 6. Question 6. Chlorine is added to 2 centimeters cubed of a dilute solution of potassium iodide. The equation for the reaction between chlorine and iodide ions is as below. So they gave us the equation for the reaction, and they said which statement is correct. Before we answer any question, we can see that chlorine is converted into chloride, and that is a reduction reaction, while iodide is converted into iodine, that is oxidation. A. Iodide ions oxidize chlorine. That is wrong, because iodide ions are the ones that were oxidized, so they cause the reduction of chlorine. And B. Iodide ions reduce chlorine. That is true, because chlorine was reduced, therefore iodide ions acted as reducing agents. So the answer should be a B. Moving on to part B. When the reaction is complete, 10 centimeters cubed of cyclohexane, whose density is 0.79 gram per centimeter cubed, is added. The mixture is shaken and left to settle into 2 layers. Which description of one of these layers is correct? We know that when we look at the equation above, we will have aqueous iodine and we'll have chloride. So when we mix cyclohexane here, iodine has a higher solubility in cyclohexane than in the water layer. Therefore, it's going to move from the aqueous layer into the cyclohexane layer, and the color will turn purple. Another thing is we see the density of cyclohexane is 0.79 gram per centimeters cubed, which is lower than the density of the aqueous layer, which is approximately 1 gram per centimeter cube. So we can conclude that iodine is going to be in the top layer, which is the cyclohexane layer, and its color is going to be purple. So the answer is going to be A. The upper layer is going to be purple. Question 7. Going from calcium to barium in group 2, which property changes as stated? Ionic radius decreases. This is wrong, because we are going down the group, and therefore ionic radius should increase. B says first ionization energy decreases. This is true, because as you go down the group, the ionic radius will increase. There will be greater shielding, and therefore outermost electrons will be easily lost. So first ionization energy is going to decrease. When you go to C, they say the melting temperature increases. That is not true. And reactivity with water decreases. That is not true as well. Continuing to question 8. Question 8. The properties of group 2 compounds change down the group from magnesium to barium. Which statement is correct? Solubility of group 2 sulfates increases. That is wrong, because the solubility of group 2 sulfates decreases. Barium sulfate is insoluble, yet magnesium sulfate is soluble. B says solubility of group 2 hydroxides decreases. That is also wrong, because magnesium hydroxide is insoluble, yet barium hydroxide is going to be soluble, so that is wrong. Thermostability of group 2 nitrates increases. This is correct. As you go down the group, because the cation is going to be bigger, there will be less polarization, and therefore more energy will be required to decompose nitrates. Even the thermal stability of carbonates will increase as you go down the group. So the correct answer here should be a C. Question 9. Iodine reacts with hard sodium hydroxide solution. So they've given us the equation for the reaction and they said what are the coefficients of A, B, C, D, and E needed to balance the equation. If you try to balance the charges, the oxidation states, as well as the atoms present, the answer should be a D. Moving on. Question 10. Aqueous sodium iodide reacts with aqueous silver nitrate to form a precipitate of silver iodide. So here we can see the reaction as given. They say which is correct for silver iodide. Here they say color of the precipitate. Of course, silver iodide is a yellow precipitate, and the solubility in concentrated aqueous ammonia, it will be insoluble. Silver iodide will not dissolve in both dilute aqueous ammonia as well as concentrated aqueous ammonia, so the answer should be an A. Question 10b. What is the percentage atom economy by mass for the production of silver iodide in this reaction? You have to look at the product here. This is the product, so we have to consider the molar mass of the product. To calculate the percentage atom economy, we will use the molar mass of silver iodide divided by the molar mass of both products times 100, or you could use the molar mass of this divided by the molar mass of both reactants times 100. You still get the same answer, which is 73.4%, and the approximate answer is 73%. Question 11. Ethanol can be prepared by reacting chloroethane with aqueous potassium hydroxide. What type of reaction occurs in this preparation? If you look at this reaction here, we are using chloroethane and potassium hydroxide. The product is going to be an alcohol and potassium chloride. So this is a substitution reaction because one nucleophile went out as another nucleophile came in. So the answer here should be a D. Question 11b. How do the boiling temperatures of ethanol and chloroethane compare, and what is the reason for the differences? I expect ethanol to have a higher boiling point because it can form intermolecular hydrogen bonds. When you look at chloroethane, it only forms London forces, which increases the number of electrons increase. However, if you compare one-on-one, a single London force and a single hydrogen bond do not have the same strength. Hydrogen bonds are stronger, and therefore ethanol molecules will have a higher boiling point in comparison to the chloroethane, so the answer should be an A. Question 11c. Bromoethane and chloroethane react with aqueous potassium hydroxide at different rates. Which is correct? If you look at bromoethane and chloroethane, the carbon bromide bond is going to be weaker than the carbon chloride bond, so I expect the bromide to break off faster. So here they say difference in rates. Of course, bromoethane is going to be faster, and the reason for that is because the carbon bromide bond is weaker than the carbon chloride bond. So let's continue on. Question 12. This is a combustion reaction. They've given us the molar mass of butanol and the molar volume of the gas at room temperature, which is 24 decimeter cube per mole. So 7.4 grams of butanol was burned completely in 16 decimeters cubed of oxygen, and the mixture of gases produced was cooled to room temperature and pressure. They ask what is the final volume of the mixture of gases in decimeter cubed at room temperature and pressure. So we need to know carbon dioxide is going to be produced as a gas. However, if oxygen was in excess, some oxygen that is left is going to be part of the final volume of gas. So I started by working the number of moles of this. Because this was completely burned, we can use its moles since they'll be limiting. So moles of butanol will be mass of butanol divided by the molar mass, which gave me 0.1 mole. And if we have 0.1 mole of this, 0.6 moles of oxygen should react. So the moles of oxygen that are required are going to be 0.6. Now I'm going to use this to find the volume of oxygen that should have been contained in the 0.6 moles. We know that volume of gas is number of moles times molar volume, which is 0.6 times 24, and that gives me 14.4 decimeters cubed. So this means in the 0.6 moles of oxygen, we have 14.4 decimeters cubed of oxygen gas at room temperature and pressure. Therefore, the oxygen that did not react should be 16 minus 14.4, which gives me 1.6 decimeters cubed. We can also determine the volume of carbon dioxide used using the mole ratio from the equation, as well as the volume of oxygen. So here the mole ratio of oxygen used to carbon dioxide produced should be 6:4. So 4/6 times 14.4, which gives me 9.6 decimeters cubed of oxygen. Here I used the volume of oxygen that reacted. The total gas left at the end should be 9.6 plus 1.6 decimeters cubed, which gave me 11.2 decimeters cubed. So my answer should be a B. Question 12b. If the final mixture of gas is passed through a U-tube containing sodium hydroxide, what is the final volume of gas in centimeters cubed? If they use potassium hydroxide or sodium hydroxide, this is going to remove carbon dioxide. And we know that of the total volume of gas left, which is 11.2 decimeters cubed, the volume of carbon dioxide is 9.6 decimeters cubed. So if we use sodium hydroxide and it removes all the 9.6 decimeters cubed, we are left with 1.6 decimeters cubed of oxygen, which is equivalent to 1,600 centimeters cubed. So our answer should be a B. Moving on. Question 13. A halogenal alkane is dissolved in aqueous ethanol, and when aqueous silver nitrate is added, a white precipitate forms immediately. When they say a white precipitate forms, when silver nitrate is used, I think of silver chloride. However, they've said that it forms immediately, and that tells me this is going to be a tertiary halogenal alkane. So they asked which is the halogenal alkane. If we look at 1-chlorobutane, this is a primary halogenal alkane. 2-chlorobutane is a secondary halogenal alkane. 1-chloro-2-methylpropane is a primary halogenal alkane. And then 2-chloro-2-methylpropane, this is a tertiary halogenal alkane. So our sample is mostly going to be D. Question 14. Propanol, whose formula is that, and propanone, whose formula is that, are isomers. Which mass to charge peak would not be expected in the mass spectrum of propanone? Here I tried to include the mass to charges. A CH3 will give us a 15, a CH3CH2 will give us 29, and a CHO will give us 29. So here we have a 29, a 58, and a 15. Here we have a 15 from CH3, we have a 43 from CH3CO, and we have a 58. So 58 is present. We can see 43 is present as well as a 15. The only peak that will be absent in propanone is going to be that at 29, so the answer should be a B. Question 14b. Propanol and propanone can be distinguished by chemical tests. Which pair of observations is correct? From A, we can use Fehling solution. That is correct. However, the observation with propanol is no observable change. With propanol, we see a red precipitate, and observation with propanone is no change. So this should be switched out, meaning A is wrong. B, they say add solid phosphorus pentachloride. That is wrong. And C says warm with acidified potassium dichromate. This is an oxidizing agent, so this could be okay because the aldehyde can be oxidized while the ketone cannot be oxidized. So oxidation of the aldehyde, which is propanol, turns from orange to green. And then with propanone, there will be no observable change because propanone cannot be oxidized. So the answer here should be a C. So this brings us to the end of this video. Thanks for being with us. Don't forget to subscribe. See you in the next video. Bye-bye.